So we are now ready to deal with the radial equation. Right, so we have this part, and our function looks like that. And so we need this part. And so what's left is, let's see, what's the equation for this? Let's go back to what we had before. There's that function, and the Schrödinger equation ends up looking like this for this part. 2 over r, dr by dr, minus 2, the mass r squared over h bar squared. Let's bring the energy to this side. So we have the potential minus the energy. That's equal to that constant, which we now know to be L times L plus 1, right? The lambda constant. We could put this in the form 2 derivatives of r in little r plus 2 over r, that term, minus 2m over h bar squared, v minus e. We're multiplying by r and dividing by r squared. So here we have r equals L times L plus 1, r over little r squared. We could put this in the form minus h bar squared over 2m, 2 derivatives here, the same term, plus VR plus h bar squared, L times L plus 1 over 2mr squared times r equals ER. And the point is we're trying to produce a familiar equation. Let's see, we know that this term, so this term comes from taking 2 derivatives of that quantity. So we can produce, what we're trying to do is produce a familiar equation for this quantity. And therefore, that means minus h bar squared over 2m, 2 derivatives in r of that quantity, plus the potential little r times big R, plus, right, because we're multiplying this by r, so we'll multiply everything by r, plus, where are we here? H bar squared, L times L plus 1, see, what do I want to do? We'll end up with a factor of well, multiplying by r here, but I want to put that into that form, so I'll keep the r squared there. And that is E times this factor. Okay, so now we have an equation for this function. Let's call it, standard thing to do is to refer to it as u. So the function u is defined as r times this capital R function, which is a function of little r. So we end up with, let's see, minus h bar squared over 2m, two derivatives in r, plus h bar squared, L times L plus 1, for 2mr squared plus v, acting on u is equal to e times the u function. So let's get another sheet. Okay, so we want to deal with hydrogen, so let's be specific. So in other words, V equals minus E squared over R, and we get minus H bar squared over 2M, two derivatives in R, plus L times L plus 1, H bar squared over 2mr squared minus E squared over R. All right, that operates on the U function, and that's equal to EU. And so that's the equation that we have, and we'll look at this for large and small values of R, and it'll look like an equation that we're familiar with. We'll be able to read off the solution, and then we have to sort of patch them together.